All right, let's try to solve this guy. X plus 4 over 5 is equal to negative 1 over 2x minus 3. So the great thing about this problem is that it is a proportion. How do we know it's a proportion? We have one fraction equal to another fraction, right? In this problem, we only have two fractions, and they're set equal to each other. We have a proportion. What do you know about proportions? We just said it.
You have to assume that they're true?
Well, that's what you do with every equation. You assume that every equation starts out as true unless you come up with a contradiction. But the cross products are equal. That means that the product here of x plus 4 and 2x minus 3 is equal to the other cross product, which is 5 times negative 1. Are you guys with me on this? So let's multiply the stuff out on the left. What do we have? 2x squared. Okay. Minus 3x plus 8x minus 12 is equal to negative 5. Now we're starting to get to the part of the semester where when we have equations, you have to take a step back and think about what type of equation is it. Okay. Is it going to be linear, where you just get x to one side and constants on the other, or is it something that's quadratic and higher, where you need to go back and use the zero factor theorem? So when I look at this problem right here, is this linear or is it quadratic? How can you tell?
It's a polynomial, so
It's going to be a polynomial. It's going to be quadratic because we've got the square here, right? That square tells me it's not linear. That means you don't get x to one side and constants on the other. It doesn't work that way. This problem says it's quadratic, so we use the zero factor theorem. So, what does that mean?
5 to the other side.
Add the 5 to the other side. So, combine like terms, what do we have?
2x plus 5x
2x squared plus 5x minus 7 is equal to 0. Now that it's equal to 0, we use what? Factor. Factor this guy completely. Well, I know that 2x squared has to break down as 2x and x. 7 is also prime, and it has to be 7 and 1, but where do the numbers go?
plus 7 minus
2x plus 7 and x minus 1. So, if I've got this, what are my solutions? What do I get from this guy? X equals positive 1. What about here? X equals negative 7 over 2. So what we're saying in this equation is that we have two replacements of the variable that could work. I could replace it with negative 7 halves and everything would be true up here, or I could replace it with 1. Now we got to be careful though before we box this stuff. Yesterday we talked about restricted values, right? We talked about those values that I can never talk about when I had an expression. Those were the values that would make my denominator what?
Undefined.
It would make the expression undefined when the denominator equals 0. So when I look up here, it's always a good idea to write out what my restricted values are. Because if I come up with a solution that matches with a restricted value, we're going to have issues. So here, is there anything that would make this denominator equal 0? No. What about this guy? When does this guy equal 0? Imagine if this guy is equal to 0 and you solve that, you find out that x equals what?
3/2.
Be 3/2. So this would be your restricted value. Did I have that as a solution down here? No, so those restricted values didn't come in the way of my answers. So as long as I've done everything correctly, these guys should work out correctly.
So we put the restricted values on the test, so they let extra points.
No, I would not give you extra points for doing something that you should do anyway. Do you guys give me extra, do I get extra points just for showing up to work? No.
It's like my mother.
Great, I'm just like your mother.